Good morning everyone. Today I am going to explain how RAID capacity is calculated and how much storage capacity we actually get from a group of disk. So we all know about RAID, but today we'll go in much detail. So before we start, let us understand one important point. When we purchase multiple disks, the total physical capacity is called as raw capacity. However, the capacity available for storing data depends on RAID level because there are different types of level we choose. Okay, so for example, RAID 5, RAID 6, RAID 0, RAID 10. So what type of RAID is required depending on our requirement. So let us first look at three common RAID what we use. The first one we use is RAID 0, which is you can see in the slide, RAID 0, and it is called as stripping. So in RAID 0, data is divided into small blocks and distributed across all the disks. So suppose for example you have two disks. So data is scattered between these two disks. This improves performance because multiple disks can read and write data at the same time. For example, if we have four disks, okay, let us take an example that we have four disks, each of 10 TB. Okay, so how much it will be? So 4 into 10 TB is equal to 40 TB usable capacity. You can see in the slide. So RAID 0 gives us the full capacity of all disks. However, there is one major disadvantage for RAID 0, that it provides no protection against disk failure. Suppose if one disk fail, then your data is gone. The complete RAID volume may become unusable because parts of the RAIDs are distributed across the disks. So RAID 0 is mainly used where performance is important and data protection is handled separately. Okay, so it is very clear. I'll repeat once again. RAID 0 is mainly used where performance is important and data protection is handled separately. Right? Now we'll talk about RAID 1, that is also called as mirroring. So RAID 1 creates an exact copy of data on another disk. For example, if we have two disks of 10 TB, the same disk is written to both disks. Okay, for example, two disks we have of 10 TB, so total raw capacity will be how much? It will be 20 TB. But the usable capacity is only 10 TB. The other 10 TB is used for mirror copy. The advantage is that if one disk fails, the second disk still contain the complete copy of your data. So finally we'll also discuss about RAID 5, which is also called as parity. So RAID 5 uses one disk equivalent of capacity of parity information. For example, if we have four disks of 10 TB each, then 4 into 10 TB, how much it will be? Around 40 TB raw capacity. One disk equivalent is, like for example, used for parity, therefore 4 minus 1 into 10 TB is equal to 30 TB. So 30 TB will be your usable capacity. The important advantage is that RAID 5 can generally tolerate the failure of one disk. So at any point of time in these four disks, if suppose for example one disk is failed, one 10 TB disk is failed, so still your data is safe and secure because we are using RAID 5. So the basic concept is RAID 0 gives maximum capacity and performance but no redundancy. RAID 1 gives strong protection through mirroring but provides only 50% of usable capacity. And RAID 5 provides the balance between capacity and performance and protection against parity. Now coming back to slide 2. So in slide 2 we will discuss more about RAID 6 and RAID 10. So now let us look at two important RAID, that is RAID level 6 and RAID level 10. So first, RAID 6. RAID 6 is similar to RAID 5, but instead of one parity calculation, it uses two parity calculations. This means RAID 6 can tolerate the failure of two disks. At any point of time, RAID 6 will tolerate the failure of any two disks. For example, let us take 6 disks of 10 TB each. The calculation is like number of disk minus 2, because 2 will be we are using for failure. So into disk size. So 6 minus 2 into 10 TB is equal to 40 TB usable capacity. That's what we are showing in the slide. So the total raw capacity is 60 TB, but two equivalent disks are used for double parity. The major disadvantage of RAID 6 is better protection. The major advantage of RAID 6 is better protection. So even if two disk fails, the RAID array can still continue to operate and rebuild the lost data at any point of time. This makes RAID 6 very suitable for large capacity storage system where the disks are very large and rebuilding can take a long time. So now let us look RAID 10. So RAID 6, I think, hope you are clear. So RAID 6, any point of time, two disk it will use for failure. Now in RAID 10 combines two concepts, RAID 1 mirroring and RAID 0 stripping. That's why it is called RAID 10. Let us take 6 disks of 10 TB each. The calculation is 6 divided by 2 into 10 TB is equal to 30 TB usable capacity. So from 6 TB disk we get 30 TB usable capacity. From total 6 TB disk we get 30 TB usable capacity. The other 30 TB is used for mirroring copies. Is it clear? The advantage of RAID 10 is excellent performance and good redundancy. However, the actual fault tolerance depends on which disk fails. If both disks in the same pair fails, that particular data is lost, may be lost. Therefore, the RAID 10 is commonly selected for application requiring high performance such as databases, virtualization, and high transaction workload. Is it clear? I'll repeat once again. RAID 10 is commonly used for application which requires high performance such as database, virtualization, and high transaction workload. So in simple term, RAID 6 provides better protection against disk failure, multiple disk failure, and RAID 10 provides excellent performance with disk mirroring. The correct choice depends on the requirement capacity, performance, rebuild time, and the level of protection which is required. So now we'll go to slide 3. So in slide 3, you can see the complete practical formula is given. So suppose if we have a strong system with 8 disks, okay. So we are giving different levels. You can see RAID 0, RAID 1, RAID 5, RAID 6, RAID 10. So let us take the example like we have 8 disks in RAID 0 into 12 TB each. The total capacity is 8 into 12 TB is equal to how much? 96 TB. So now let us calculate the usable capacity for different RAID level. So for RAID 0, the formula is number of disk into disk size. So 8 into 12 is how much? 96 TB. We get the complete capacity, but there is no disk failure protection. Is it clear? RAID 0, we are getting full complete capacity, but there is no disk failure protection. In RAID 1, the capacity is approximately half of the total capacity in RAID 1. So 8 divided by 2, how much? 12 TB. So is equal to 48 TB usable. So here capacity becomes half. and mirror copy because the other half is used for mirror copies. For RAID 5, one disk equivalent is equal for parity. Okay, so for RAID 5, one disk equivalent is used for parity. So 8 minus 1, how much, into 12 TB is equal to 84 TB. That's why in RAID 5 the usable raw capacity is how much, 84 TB. So in RAID 6 what will happen, two disk equivalent are used for double parity. So here what will happen, here we are using two disks, so now it will become 72 TB. So you can see the different calculation, and now there is one important point to remember. These are all theoretical, okay, or raw usables capacity calculation. The actual capacity available to the user may be slightly lower because of RAID controller overhead. There is something called RAID controller overhead, formatting, file system overhead, hot spare disk, so storage system metadata. So all these factors we need to consider. For example, if we have 96 TB raw capacity, we should not always promise the customer exactly 96 TB of usable storage. We must first consider the RAID level, the required protection, the hot spare, formatting overhead, and the storage system architecture. So the final message is RAID 0 gives maximum capacity but no protection. RAID 1 provides mirroring and strong redundancy but uses 50% capacity. RAID 5 provides a balance between capacity and protection. RAID 6 provides protection against two disk failure. RAID 10 provides excellent performance and redundancy but uses 50% of the raw capacity. Therefore, when designing a storage solution, okay, so when we are designing the storage solution, we should be very clear about the raw capacity. We should not look only at the total disk capacity. We should calculate the actual usable capacity based on the RAID level and the required level of data protection. So hope you might have understood the RAID level, different types of RAID level, and in next class I'll be teaching more about this. Thank you very much as of now.